Now friends, as I said, we are going to learn how to construct a similar triangle given an original triangle, right? So if a triangle, all the dimensions are given to us, then we can construct a triangle, right? That we have already learned in the chapter of construction of triangles. Now, once a original triangle is constructed, how to construct another similar triangle given the scale factor is what we are going to learn here. But before that, let's learn what a scale factor is. Although we have touched upon this concept earlier, let's see what exactly scale factor signifies. Scale factor is nothing but a ratio which indicates on how does the similar triangle or the similar figure is going to vary in size with respect to the original figure, right? So generally scale factor is denoted by K, but here we will denote that as a ratio M upon N, right? Let's say the scale factor is 2. So when I say 2, it's 2 upon 1. That indicates that the new triangle, since we are talking about triangles here, let's just stick to triangles and not say figures anymore, because although the scale factor technique is applicable to other figures as well, but here let's stick to triangles. So if let's say the scale factor is 2, that means it is 2 upon 1, that clearly says that the new triangle has to have its corresponding sides, has to have its sides twice as compared to its original corresponding sides. So basically if we have a triangle over here, then if the scale factor is 2, then the similar triangle needs to be double in size as compared to the original one. We also have dealt with how the areas of the new triangle is going to get affected. It is going to get 4 times because the ratio here is 2. The corresponding side is going to grow in length twice, right? If the scale factor is 2, one particular side is going to get doubled as compared to, that is going to happen with the other 2 sides as well. Area is going to get 2 square times. So basically area is going to get 4 times, although that is not the point of concern of this chapter. Here we are going to learn how to construct the new triangle as compared to the original one, right? If the scale factor is known. So as we said, if the scale factor is 2 upon 1, that means the upper number here indicates that how many parts it is going to get increased as compared to its original figure. So the denominator generally tells you about the original figure side, and the numerator generally tells you about the new figure which you have to construct, the new triangle that you have to construct. To see the other side of it, let's say if the scale factor is half, then that means that the new triangle needs to have its sides half, basically 50% reduced as compared to its original corresponding sides. That means if I have a triangle, let's say this one, now I have the scale factor of half. That means I need to reduce this, all these sides by half, and make a new similar triangle to this, which will look like this. So basically both of these are similar triangles, but their corresponding sides are in the ratio 1 upon 2, right? 1 being that and 2 being this. So basically the original triangle will have all its sides double as compared to its corresponding sides in the new triangle. So this scale factor, whenever it is greater than 1, indicates that the new figure is going to get enlarged, and when the scale factor is less than 1, it indicates that the new figure is going to get contracted or compressed, right? Keeping the shape same. That is what similar figures are. The shape is going to be same, the size is going to vary. Here what we have to understand is M always will indicate the new figure, new triangle, and N will always indicate the original triangle. Now, the first thing that we are going to learn in this section of constructing a similar triangle is when the scale factor is less than 1. So basically, when M upon N is less than 1, that means that the new triangle, which is always the numerator, is going to be smaller as compared to the original triangle. So basically first we are going to learn about contraction. If we have a triangle and we have to compress it to another similar triangle which has its sides lesser as compared to its corresponding sides in the original triangle, how to construct that particular triangle is what we are going to learn in this section. So we are going to have a generalized outlook to this first, and then again we'll take a problem to see how exactly to implement this algorithm in a problem, right? So the first thing that we have to do is construct the original triangle. So that is something which is quite understood. Given the dimensions of a triangle, we have to construct the original triangle. So I'll write construct the original triangle ABC. So if we have already learned how to construct triangles given its dimensions, so let's say we know how to do that, and here is how we have drawn the original triangle ABC. So the original triangle is taken care of. Now we have to draw a similar triangle whose scale factor is less than 1. That means now we have to draw another triangle which is smaller than this, right? So let's see what exactly has to be done to do that. So as we can see, we have the triangle ABC with us. The next step that we have to do is draw ray AX. Below AB. So as you can see in the construction, this is how it goes. We have to draw a ray AX with not any particular angle. This is something that we had learned in the very first slide of the chapter. Any random acute angle you need to take and draw it downwards like this. So we have a ray AX. Now we have to play with these numbers M and N. Naturally N is larger, M is smaller. That is why the ratio M upon N is less than 1. And always remember, M will represent the new values and N will represent the original or the old values, right? Now we have this triangle ABC, we have AX as the ray. What we have to do next is, again as we had done in the very first concept of this chapter, we have to draw intercepts, draw or cut intercepts on ray AX. Again we have to take a small length on the compass, keep the pointed edge on A, cut a particular point keeping the same length on A1, pointed edge, then A2, then A3. We have to go on till AN. So draw cut intercepts on AX and get points A1, A2, A3 till AN. Now N is this number which is going to be the larger number in comparison to M, and we have to make sure that AA1 is equal to A1, A2 and so on. Now this is something that we have done already, and this will go on till AN minus 1 AN. So all these intercepts have to be same. Now after doing this, the next step is to connect AN to point B, the point B which is known to us on the horizontal axis. So the next step that we have to do is connect AN and B. So as you can see in the construction, we have connected AN to the point B. After this is done, what we have to do is find out point AM, right? Now we already know that M is lesser than N because the scale factor is less than 1. M has to be necessarily less than N. Now once that is known, what we have to do is find out AM. AM will be somewhere in between of these intercepts starting from A1 to AN. AM will be somewhere in between. Now from point AM, what we have to do is draw a line parallel to this recently joined segment ANB. We have to draw a line parallel. So the next step would be draw or construct a line parallel to this newly drawn segment ANB. So now we have already seen how exactly to draw a line parallel to a given line. So what we are going to do is we need to make sure that angle, this particular angle BANA, is equal to the new angle that we are going to draw, because if there are parallel lines, we need to have corresponding angles in this case. So what we are going to do is keep the pointed edge on N, draw an arc, keep the pointed edge on AM, draw the same arc. First we have to draw that arc on AN, right? So this angle needs to be equal to this angle, so we'll draw an arc over here. Then we'll measure that particular arc length. We'll come here, keep the pointed edge at AM and cut a particular arc, get the point, and then connect them to get a parallel line to the recently got segment A and B. So once we have got a parallel line, this parallel line will intersect the segment AB, which is one side of the triangle. So wherever it intersects, that point becomes the point B dash, which is the second point of the new triangle that we want to construct, B dash. So basically B dash is the second point. So once we draw a line parallel to A and B, this line cuts AB at B dash. So let's mark that point B dash. So we have got another point of the triangle that we have to draw, the new triangle. The point A, the original point A, is still the point A dash. That point will remain the same. Now once that is done, the next step is, the next target is to find out the point C dash, which is the third point of the triangle. So what we are going to do is, after we get B dash, we have to draw a line parallel to BC. Draw a line parallel to BC from B dash. So basically we already have, so now on that note, I remember that here we have written draw a line parallel to A and B. So when we are drawing a line parallel to A and B, we have to start this from AM, right? That's what we have done in the construction. So likewise, even here what we have to do is draw a line parallel to BC starting from B dash. So again the same technique that has to be done. So we'll draw a line parallel to BC from B dash, and wherever this particular line intersects the original line, which is AC, then that particular point becomes C dash. Draw a line parallel to BC from B dash, and where it intersects AC, that point is C dash. Once you have got C dash, you have got all the 3 points. A, the original point, still is the new point A dash. So A and A dash is same. We have got B dash, we have got C dash, already connected all the 3, and hence the triangle A, B dash, C dash becomes the similar triangle to the triangle ABC with the scale factor m upon n less than 1. As you can see, the new triangle that is formed is smaller, so basically compressed in size as compared to the original triangle ABC, but definitely both of them are similar, because already you know that there is one common angle, which is angle A, and again we have the angle ABC same as the angle AB dash C dash, right? Because that's what we used to draw a line parallel. So that is what we made sure that these angles are equal. So definitely by AA test, both the triangles AB dash C dash and ABC are similar to each other. So we have made sure that we have drawn a similar triangle, and at the same time maintained the scale ratio of, or scale factor, m upon n. So now, after understanding this technique of drawing a similar triangle, let's take an example and see how exactly to implement this technique. The question says, construct a triangle ABC where AB is 5 cm, BC is 6 cm and AC is 7 cm. After constructing this triangle, construct a similar triangle whose corresponding sides are 2/3 as compared to the sides of the triangle ABC. So now we know that what we have to do. This question exactly fits to this algorithm. So if we follow this particular algorithm, we have seen that we can draw a similar triangle. The first thing that we have to do is construct the original triangle ABC, a simple enough thing to understand. So we have triangle ABC, where it is given that AB is equal to 5 centimeters, BC is given as 6 centimeters and AC is given as 7 centimeters, right? So what we are going to do is simply draw AB as the base. So we have AB as 5 centimeters, simple thing to understand. Then we have AC as 7. So keeping the pointed edge at A, we are going to cut an arc of 7 centimeters somewhere up. Likewise, BC is 6 centimeters. So keeping the pointed edge at B, we are going to cut an arc of 6 centimeters somewhere up. We are going to use rulers to basically measure the lengths. So using a ruler, we are going to take 7 and cut an arc AC. Using the ruler, we are going to take 6 and cut an arc BC up, keeping the pointed edge at B. Once we draw both these arcs, they are going to cut somewhere. Wherever they cut, that is point C, right? So when we connect C to A and B, we have triangle ABC in front of us. So ABC is created. The first step is taken care of. The second step is draw ray AX below AB. So that is simple enough to understand. Any acute angle doesn't matter. So we take a ruler, keep one point here at A, draw a ray AX. So we have a ray AX in front of us. Now, after that, our job is to have equal intercepts, but we have to make sure that we have n points. Now, let us explore about that a bit more. We have been given that we need a similar triangle with the ratio 2 by 3, right? So basically the scale factor is given to us as 2 by 3. So obviously we need to compress the triangle. So the similar triangle that we are going to draw is 2/3 in size as compared to the original triangle which is already drawn here. So as we have seen here, we need to have n points, right? And get points A1, A2, A3 till AN. So basically we need to write that here as well. N points is the focus because n is the larger value, as we can see here. Even in this scale factor ratio, n is larger, which is 3. Right? So whenever there is a compression happening, the original number will be greater, which is 3 in this case. So all that we have to do is 3 points on the ray AX, take a particular length on the compass, keep the pointed edge on A, cut an arc on that ray AX, we'll get point A1, keep the pointed edge on A1, cut an arc, get a point A2. Similarly, we get the point A3. So we have the 3 points required, A1, A2 and A3 on the ray AX. Once that is done, the next step is simply to connect AN and B. In this case, AN is nothing but A3 because that is the last point. So connect that with B. Again, a simple thing to do. So just take a ruler and connect A3 and B. Once that is done, the next step is interesting because the next step says draw a line parallel to ANB, in this case A3B, from AM. Now what is AM? AM is nothing but A2. So this particular step signifies draw a line parallel to A3B, the segment that we have just drawn, from A2. So we have to pick up A2 and then draw a line parallel to the segment A3B. And we know how to draw a line parallel to a given segment just by making sure that the angles are equal. In this case, these will be corresponding angles, as you can see. So simple enough to understand. We'll have an arc here, keep the same length and make an arc here as well. Once that is done, we have to measure the arc length, cut the arc length over here and then join the points to get a line parallel to the original line A3B, original segment rather A3B. Now this particular segment or line that we have drawn from A2, it will be actually a ray because A2 is fixed and the other end is open, right? And wherever it cuts the segment AB, the base of the triangle, that point will become B dash. That is what even this algorithm says, that this line cuts AB at B dash. So at AB, wherever it cuts, that point is B dash. So we have got the second point of the new triangle that we have to draw because the first point is the original point A itself, right? So we have got B dash. The next step asks us to draw a line parallel to BC from B dash, right? So we have BC in front of us, B dash we have recently obtained. So what we have to do is draw a line parallel to BC from B dash. It's simple enough to do. What we have to do is just measure this arc, measure as in make a cut over here, arc over here, the same arc over here. Then measuring this arc length, we have to go here and then cut this particular thing. Once we cut, we get a particular point. Connect that point to B dash, extrapolate it and this is the line which is parallel to BC. So this line which is parallel to BC now cuts AC somewhere, and wherever it cuts, that point becomes C dash. So we have A, we have B dash, and we have C dash, and hence we have successfully drawn the triangle AB dash C dash, which is similar to the triangle ABC, but the corresponding sides are in the ratio 2:3 as compared to the original side. So basically we have compressed the triangle ABC with the ratio 2:3 by using this technique. So now, after knowing this, next we are going to do the same thing where we are going to draw a similar triangle, but this time the scale factor is going to be greater than 1. So more or less a similar method, but there are going to be important deviations from this which we are going to learn in the coming section of constructing a similar triangle with scale factor greater than 1.